All right, welcome back to the drive-through. Sponsored as always by the deli. Hungry? Stop by the deli. Make yourself a sandwich. Okay, we are in 3-5, overlapping triangles. The good news is there's nothing new to learn here, but the bad news is that the proofs get harder. So you're going to have to spend some time on these, and I'll try to give you as much support as you can. Hopefully you're up for the challenge because that's what you signed up for, and it's good for you. We're given that AC, this entire segment, is congruent to AB. So we got that. And we also know that this small part is congruent to this small part. AD is congruent. So we're trying to prove that CE is congruent to BD. And it's hard until you pull the triangles apart. So if I just could pull those apart, we got an A up here, we got a D here, and we got a B here. And then on the other side, you've got an A here, an E here, and a C down here. Now look, let's label what we're given. We know AD is congruent to AE, and we also know that AB is congruent to AC. So it's screaming side angle side, but maybe you wouldn't have seen that. Look, angle A is congruent to angle A. So I've just kind of done the proof in my head. But I don't know that you would see that. If I could use my highlighter, I don't know that you would see that that triangle is congruent to that triangle if you didn't peel them out and take a look at all the things we're given. So we're actually given enough information to do this pretty quickly. Okay? AC is congruent to AB, and AE is congruent to AD. That's given. Okay? I can say that angle A, and I can call that angle A because it's the only angle A that there is congruent to angle A, and that's reflexive. Okay, so now I've got enough to prove that triangle. Let me make sure I get the order right. A, D, B. That doesn't matter. I can choose any order I want for that. But now that I've picked A, D, B, it's got to be A, E, C. And that's going to be side angle side. And I can say CE is congruent to BD. And the reason for that would be C, P, C, T, C. Okay, so one of the hardest short proofs that you'll have. Let's try one that's a little more difficult. Okay, given FH is congruent to MJ, G and K are midpoints, bless you, and GHJ is KJH. Okay, I think I can see the triangles that I need to pull apart here. These pictures don't have to be perfect. You just need something that'll help clean up this messy picture. And so that's why I'm going to re-widmapoi, if you will. Okay, so what am I given? Well, I know that HJ is congruent to HJ. I'm going to be able to come up with that by reflexive. And G, so those are the only parts of the triangle I can get pretty easily. So we're going to have to work for the other parts. So let's get started. I think we're going to definitely use segments division on this one. We're given, well, I won't do it. Yes, I will. That's all right there. Okay? That'll just save this video a little time. We're given all this stuff. Okay? Okay, now I apologize. We're trying to prove that GJ is congruent to KH. Okay, so what I'm going to say, since FH is congruent to MJ, and point K and G are the midpoints of both of those, then I can say directly that GH is congruent to KJ, and that is not definition of midpoint, that is segments division. Okay? So, I'll say GH is congruent to KJ by segments division. So look, I got a side here, I got an angle here. I need one more piece of information, and I can tell by my picture it's going to be a side. So I need to say that HJ is congruent to JH. You could also say HJ there. That's the reflexive property. Okay, now I can say that triangle GHJ is congruent to triangle KJH. And that is SAS postulate. So I should be able to say that GJ is congruent. Let's make sure it matches up. GJ, KH, beautiful. GJ is congruent to KH by CPCTC. Boom!